Welcome to this video. Today we will learn about PLC components and their functions in an industrial automation system. In the past, industries relied on relay logic control (RLC) to automate the processes. However, troubleshooting faults and modifying RLC circuits was time consuming and required a lot of space. To overcome these limitations, programmable logic controllers were introduced. A PLC is an industrial computer designed to automate processes efficiently and reliably. To configure PLC hardware, we will prepare 3 racks and labeled as Rack 1, Rack 2 and Rack 3. And in rack number 1, we have added power supply base plate and power supply module. In rack number 2, we have added power supply adapter, base plate, central processing unit, bus network module, Ethernet interface unit. And in rack number 3, we have added 7 components: network interface unit, I/O terminal unit, rack power supply module, digital input module, digital output module, analog input module, and finally analog output module. This configuration is based on the GE Fanuc PLC, which I have worked with it. It is a robust and reliable system. Now let's explore about the rack by rack. First, we will install power supply base in rack number 1. Then, we insert 2 power supply modules, one as the main power supply and other as the standby backup for redundancy. In rack 2, we first install the base plate. Next, we insert the power supply adapter. Then, we install the central processing unit CPU, which is the brain of the PLC system. After that, we add the bus network module, which facilitates communication between different racks. Finally, we install the Ethernet interface module for network connectivity. And we leave 2 slots empty for future expansion. In rack 3, we begin by installing the network interface unit. Next, we attach 5 number of I/O terminal units one by one. On the first I/O terminal unit, we plug in the rack power supply module. On the second I/O terminal unit, we insert the digital input module, which receives signal from sensors and switches. On the third I/O terminal unit, we install the digital output module, which controls the actuators like relays, solenoids, and motors. On the fourth I/O terminal, we insert the analog input module to process the sensor data such as temperature, pressure, and level. And finally, on fifth I/O terminal, we install the analog output module, which sends signal to the control devices like VFDs and proportional valves. This completes the PLC hardware configuration. In part 2 of this PLC training series, I will explain the functions of each component in detail. Stay tuned and keep watching.